This video is going to quickly show you how to use CINEBENCH, a utility from Maxon that allows you to benchmark or get an idea of how fast a computer's CPU or its processor and its GPU or its graphics card are on a particular machine. To get CINEBENCH, it's very easy. Go to Google, CINEBENCH, and then it's going to be, like most things with a strange name, first result. Go ahead and click on that, scroll down, and you'll download the one for your operating system. From this point, the steps are almost identical. We're going to be using the Mac one, but the Windows one is identical in every way. All the controls within the application itself are the same. Once finished downloading, go ahead and open up the folder. And inside, you'll see a number of things, but we only care about the actual CINEBENCH application itself. It doesn't need to be installed. You can run it from this location right here. Go ahead and run CINEBENCH OS X. It'll be called a Windows one on Windows. And it'll open up. Now, the preview window here, go ahead and accept. Nothing worried about in there. There's two different benchmarks that it can do, OpenGL and CPU. However, what we're going to want to do is go to File and Advanced Benchmark. Then we're going to want to make sure all these are checked. So they currently should start out default checked. And then we're going to go to File, and we're going to run all selected tests in just a moment. What I wanted to explain was a few of the things here. Down here you have other commonly ranked CPUs or GPUs. So in OpenGL, that's the test for the GPU, you can see what their score was. These are different machines that just sort of give a sampling across the range. So very, very bad cards and very, very good ones up here. However, once you benchmark, you'll see a number of different results listed because it's going to try to show you results that are similar to yours to give you an idea of where your system stands. Here you'll see the hardware that the CINEBENCH determines that your machine has. If you disagree with the information that lists here, a lot of the time that can happen on Windows, and it just means you need to update your drivers. On Mac, it'll almost always be exactly correct. And we'll go ahead and go to File, and we'll choose Run All Selected Tests. The first one it's going to run is the OpenGL benchmark, which is a video benchmark. And now, since that's based on resolution, what CINEBENCH does is it'll make sure that the scene that it's rendering is always the same resolution. I believe it's maybe 1080p or a little smaller than that. So this scene, yeah, it looks like 12 by 10. So this scene is going to render smaller. So no matter how large resolution or how high a resolution you have on your screen, this scene is going to render at the same size to give the same benchmark. So if you have a lower resolution, this will be larger. If you have a high, like a 5K screen, this might be a smaller image. Don't worry about that. It doesn't change the benchmark. It's done that way intentionally. We'll let the benchmark finish out here. It's a simple car chase scene, and it checks things like shadows, light bouncing off of other objects, and things that are moving actively in OpenGL. This is the part of Vectorworks that uses Vectorworks, the 3D views, top plan view, and then OpenGL views will use this rendering and this setting. Now we're done. We got a score of 45.59 frames per second, and you can see where that ranks. So there's my card, and you can see up here Radeon HD 5770 and a GeForce GT 650 both beat my card, but my card handily beats the very bad Intel graphics down here and an older GT 620. So this is just showing you where your machine stands in the benchmark rankings versus other machines. What it's doing now is a CPU test. So you can see here, these are called render buckets. And you might have noticed them in Vectorworks itself because we use the same rendering engine that you're seeing in use here. Each of these is a number of cores. So since my machine has 8 cores, I'm seeing 8 render buckets happen at the same time. If you had 32 cores, you would see 32 of these spin across the screen. And if you had 1, you would see only 1 of them. It's going to render these all, and this is going to finish. And depending on how fast this scene renders, that's how fast your machine is when it comes to rendering, specifically for multi-core rendering. Generally, RenderWorks is where this is going to happen. The next scene we're going to see, however, is what's called CPU single core. So it's only going to use 1 core of the CPU, so you'll see 1 bucket, and it's going to render the entire scene with just a single bucket instead. There, this multiple core finished, and now we're going to see the single core, which is basically the same scene, but only a single core. And I'll go ahead and speed this up since this takes much longer than the original render. And there we are. So now you can see something a little interesting. Even though that was 8 cores versus 1 core, this will not be 8 times higher than that score. You get an MP ratio, which is a multiprocessing ratio, which means that this processor in particular can do things about 4.5 times faster for all 8 of its cores than it can if it just uses one of its cores. That has a little bit to do with how fast the core is clocked, about how good the cooling is, and a number of other features. But there's only a little bit to be concerned about with the single core. The single core is how fast you're going to be able to do operations like geometry calculation, moving geometry, 3D solids calculations, things like that. However, that score is not going to affect the speed very much. One that had a single core score of 200 is not going to be in Vectorworks twice as fast as a machine that had a single core score of 100. When it comes to the regular CPU, however, if I have a score of 530, if I'm doing a RenderWorks rendering, and I have another machine I'm comparing this to that goes 1060, that 1060 machine is, on average, going to be twice as fast at RenderWorks renderings than this machine that's 530. OpenGL is a little less cut and dry. You'll see here we have a number of charts of different machines that we've benchmarked here that we have in-house that we ran the benchmarks on, and you can also, linked here in the article, find a number of different public comparison ones where people have uploaded their resulting scores directly from Cinebench. And you can get an idea of what machines will give you the kind of scores you're looking for. Now, as long as you're meeting the minimum system requirements for Vectorworks, Vectorworks is going to be able to run these benchmarks, and using them to compare when you're getting a new machine or upgrading an existing machine. Most of the point of that is so that you can see how much faster or how good your experience is going to be. Vectorworks will still run on machines that have lower scores as long as they're within the minimum system requirements. It's simply that they will not run as well. So a higher FPS score is going to translate directly into a smoother experience, or a smoother experience with much larger files than a machine with a much lower OpenGL score. And with CPU, the same for RenderWorks. If you do rendering all day, every day, you can get 5 times the rendering done with a machine that's 5 times as fast. But you need to know what that is. So this gives you a reference point and information you can use to determine if your upgrade is going to be worth the money for you. So if you're looking at a new machine, then it costs $3,000 and you're not going to be selling the old one to recoup any of that cost, and you only see a 10% difference, it's up to you to judge whether a 10% faster rendering is worth $3,000. Thank you for joining us, and don't forget to visit kbase.vectorworks.net for more video tech tips and other technical articles. Thank you, and have a great day.